video. Today we are talking about atomic structure, science for class 7. Atomic structure, science for class 7. Right? We know that whatever we see around us, whatever has mass, whatever occupies space is called matter. Matter can be divided as elements, compounds and mixtures. That is a classification. Elements are the simplest substance that we can have and an indivisible part of that element is called an atom. Compounds are combinations of one or more elements. The atoms of elements combine together chemically in a definite proportion to form a compound. The indivisible part of a compound is called a molecule. The elements are represented by a symbol that is H or C or O, etc., while the compounds are represented by their chemical formula that is H2O. And then we have mixture like air, which has elements, which has compounds, everything put together. There is no definite proportion. Mixture can be separated by physical or chemical means. Compounds can be separated only by chemical means. The properties of the compound may not be same as the properties of the constituent elements. So all these things we have a basic understanding about the matter around us, right? Now, if this is matter, the solids, liquids and gas, these are the matter, the metals and non-metals and metalloids, the compounds and mixtures, this is matter, and this is a molecule. Molecule is the smallest indivisible part of an compound. These molecules have atoms. Atoms are the smallest indivisible part of the constituent elements of a compound. Atoms have what is inside this is a nucleus, and this is electron. These electrons circle around the nucleus in their own orbits. So this nucleus has protons. Nucleus has protons and neutrons. Protons are positively charged, electrons are negatively charged. And then we have a neutron which has no charge. The number of proton plus number of neutron together gives you the atomic number. The number of electrons gives you the atomic number and atomic mass. So this is the mass number and atomic number of an atom. And then this proton can today be further divided into quark. Quark is a quark up and quark down. Mu and D, quark up and quark down. Dalton's theory, from there it comes. There is also called a gluon. From proton, people have now been able to identify something called strings also. This is the matter to atom to proton to quark to string path of subdivision of learning the atomic part of the elements and compounds. So atom is 1 and 1,000 times smaller than the thickest human hair. 1 and 1,000 times smaller than air. Human hair, how thick or how thin it is, you already know. Atom is 1 and 1,000 times smaller, that is 1 by 1,000. So diameter of an atom is 0.00001 this many meter. So how do we write? Now how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. If there are 9 zeros after a decimal, we write 10 power minus 9. 1 and 0, 10 is represented as 10 power 1. Number of zeros after 1, 10, 100, 1000, we represent as 10 power 1, 10 power 2, 10 power 3. When it is after decimal, as many number of zeros that you will write. So 9 zeros after decimal, 10 power minus 9. So 10 power minus 9 meter is the diameter of an atom. Radius is half of that. So atom is 1,000 times smaller than the thinnest air. So 10 power minus 9 meter is the diameter of an atom. What is diameter? Radius is from the center point to the end of the circle is radius. From one end of the circle to another end of the circle is a diameter when it is passing through the center. If it is passing through anywhere else, then we call as a vertex or an arc, etc. Right? 10 power minus 9 meter. So we cannot write 10 power minus 9 meter. So we need another unit of measure, nanometer. Nanometer is the smallest unit used to measure small length. So 1 nanometer is 10 power 9 meter, 10 power minus 9 meter. Nanometer is 10 power minus 9 meter. So 1 meter is 10 power 9 nanometer. 9 times, if you write 10 into 10 into 10, that many nanometer is 1 meter. So nanometer is 10 power minus 9 meter. So what is the diameter of an atom? Diameter of an atom is 1 nanometer, because diameter of an atom is 10 power minus 9 meter. Nanometer is 10 power minus 9 meter. So this is the smallest measures, right? Now Dalton proposed atomic theory. There were 3 important people who proposed atomic theories: Dalton, Thomson and Rutherford. What did Dalton say? John Dalton, he did the research on atoms between 1803 and 1808. And then he said matter consists of very small particles. Atom is the smallest indivisible particle and it is spherical in shape. So John Dalton, for his research in 03 to 08, 1803, 1808, found out matter consists of small particles. It is indivisible particle is called atom. It is spherical in shape, right? And then came Thomson. Thomson did the research from 97 to 1904, 1897 to 1904. J.J. Thomson. So what did J.J. Thomson say? J.J. Thomson said atom is like a plum pudding or a watermelon. Atom is like a watermelon or a plum pudding. What does it mean? It has positively charged part like the red part of the watermelon. The center part is a positively charged part. Then it has a negatively charged part which are embedded like seeds. Negatively charged part is embedded on the red part like seeds, that is electrons. So this is what he said. You have a positively charged part and then you have a negatively charged part embedded here and there. That is what Dalton also said. Dalton also said very small particle, indivisible, spherical in shape, right? This is what he said. What did Thomson say? Thomson said like seeds, electrons are embedded on a positively charged part. So he found out there is a positive and negative charge. There is a positive and negative charge. He also discovered positive charge is almost in the center, negative charge are spread out, embedded like seeds. Atom as a whole has no charge. He said this positive and negative will offset each other, So he just found out the shape and indivisible part, but he found out there is a positive charge, there is a negative charge, net it will offset, these are embedded, and so he got a Nobel Prize in 1906 for this finding, for this discovery. Then came Rutherford. He was doing the research from 1911 to 1977. Thomson's research was 1897 to 1904. After that, Rutherford came. What did Rutherford do? He bombarded a thin layer of gold with a positive charged alpha rays. He bombarded a layer of gold with alpha rays. Most of the rays which travel at a great velocity passed through the gold sheet. When the rays are passing alpha rays, positively charged alpha rays with a great velocity, they did pass through the gold sheet without any obstacle. But some of the rays, few and far in between, were turned back. So most of the positively charged rays passed through the thin layer of gold without any difficulty when they are at great velocity. Some of the rays, though they were positively charged alpha rays, were passing at the great velocity, the thin layer of gold returned them. So then he found atoms consist mainly of empty space. That is why most of them are passing through. Atom consist mainly of empty space. So these were passing through. Few were returned because there is something that is hitting this positively charged ray. Apart from the positively charged particles, part of the positively charged particles returned back is positively charged. So nucleus at the center of the atom has a positive charge. He said nucleus at the center of the atom has a positively charged. He said positively charged part like a red part, red of the watermelon. He said no. Center of the atom has a positive charge, not spread like the red of the watermelon. Center of the atom has a positive charge. Most of the mass of the atom is concentrated in the nucleus. Most of the mass of the atom is concentrated on the nucleus. Rest of them is empty space. Most of the matter of the atom is in the nucleus, rest is empty space. Overall very small in size. The nucleus is overall very small in size, but mass is there only in the nucleus, rest is an empty space. Part from which the positively charged particles are turned back is called positive. Positive and positive, when they hit each other, positive is returning. That is what he found out, right? Negatively charged particles revolve around the nucleus in specific orbit. Rutherford is the one who found out there is a specific orbit for the negative particles. He got Nobel Prize for chemistry for this. 1911 to 1977 he did this research. So Rutherford found out that alpha rays positively charged, when they move at great velocity on a thin layer of gold, most of them will pass through because atom is mostly of empty space. Some of them will come back because most of the mass of the atom is concentrated in the nucleus, and nucleus is at the center, and at that center they have the positive charge. So the rays were returned because there is something called nucleus which has the most of the mass of the atom. It is concentrated at the center of the atom. Rest of them is empty space. This nucleus at the center is of positive charge. And whatever is negatively charged, they revolve around the nucleus on a specific orbit, and they are of very minuscule size, and that is what he did. Then came Bohr's atomic theory. Bohr's atomic theory started talking about the energy levels of an atom. He found out this theory or discovered or proposed this theory in 1913. Then in 1926, Schrodinger came. What did Schrodinger say? He said there is an electron cloud. There is an electron cloud, cloud of electrons, right? This is the evolution of the atomic theory. So we have Dalton, Thomson, Rutherford, Bohr and Schrodinger. Now, what is subatomic particles? Atoms of all elements are made up of smaller components. Atom is the most indivisible part of an atom. All atoms of an element are similar. All atoms of an element display all the characteristics of the atom. Atoms are having smaller components. They are called electron, proton, neutron. Proton and neutron together are called nucleons. Whatever is within the nucleus is called a nucleon, proton and neutron. Then you have electron outside the nucleus. Proton and neutron together have the mass of the atom. Electrons revolve on specific orbit around the nucleus. The electron from the hydrogen atom is no different from electron of carbon atom. All electrons are almost the same. Earlier we found the atom of one element is not same as atom of another element. We found that atom of hydrogen and atom of chlorine are different. Now we find electron of hydrogen is no different from electron of carbon. Most of the electrons are same. And proton and neutron are called nucleus. So nucleus is what decides the unique characteristics of an atom. That is what was found out after we discovered the subatomic particles. So what about proton? Proton is 1.67 into 10 power minus 27 kilo. The size of an atom we know is 10 power minus 9 meter. Diameter is 10 power minus 9 meter called in nanometer. Now proton size is 1.67 into 10 power minus 27 kilo. 1.67 into 10 power minus 27 kilo is proton. Proton and neutron together is in the nucleus, nucleons. They are positively charged. They are located in nucleus and their positive charge is same magnitude as that of the electron's negative charge. Magnitude means what? One positive, one negative. Two positive, two negative. The two or one is called magnitude. Measure is called the magnitude. The positive charge of the proton is same as the negative charge of the electron. Same magnitude. Proton size is 1.67 into 10 power minus 27 kilo. P is the representation. N is the representation of neutron. What is neutron? It is again inside the nucleus. It is not charged. It does not have any charge. It is inside nucleus. This is charged. This is not charged. Nuclei of all atoms contain neutron. All atoms contain proton. All atoms contain neutron. But then this electron or neutron can undergo a change. One proton extra, one electron extra can happen. Neutron will be, nuclei of all atoms will contain neutron. Hydrogen is called protium. The neutron, in hydrogen there is no neutron, it is called protium. Otherwise, nuclei of all atoms contain neutron. Hydrogen doesn't have it, it is called protium. Right? About protium, here also you will find this is proton, glucon, quark, neutron and all. So this subdivisions, this whatever is inside, this is U, U, D is mu, mu, D and these are the strings that you have on the outer sides, right? This is the proton and neutron. So what we know is neutron is 1.674 into 10 power minus 27, 1.6726, 673. 1.673 into 10 power minus 27, 1.675 into 10 power minus 7, 673 minus 675, 0.002 is the difference between proton and neutron weight, 10 power minus 27 kilo, right? Then we have electron. What is special about electron? Electron, it is represented by E. It is 9.1 into 10 power minus 37. It is 1.675 into 10 power minus 27. This is 10 power minus 31. That means what? The weight is very little. Electron weight is very little. That is why we say proton and neutron together form the mass. This is 10 power minus 27 kilo. This is 10 power minus 31 kilo. Negatively charged, revolve around the nucleus, not inside the nucleus, revolve around the nucleus. Mass of an electron is negligible. Mass of an electron is negligible as compared to that of the proton or neutron. Proton and neutron have mass. This is negligible. Why? 10 power minus 27, 10 power minus 31 is what? There is a difference of minus 4. That means what? 1 by 10,000 is the difference. Mass of an atom depends on the number of proton and neutron in the nucleus. Mass of an atom depends on the number of proton and neutron and not on the electron. Why? Mass of electron is negligible. The difference is 10 power minus 27 and 10 power minus 31. That is a difference in weight. That is 10 power minus 4 is almost a difference in weight, which means 1 by 10,000. Trivia. What is trivia? 7 billion atoms are there in human body. How many? 7 billion atoms. How many zeros are there in billion? I don't know. 1 zero is 10, 2 zeros is 100, 3 zeros is 1000, then you have 10,000, 100,000, million, then you have a billion. 7 billion atoms in human body. Almost 98% of them are replaced every year. That means what? We are creating almost 6 billion atoms every year we are creating in our body. Our body is having mass, occupies space. So it is made up of matter. Matter has elements and compounds and mixtures. So you will have atoms and molecules in your body. 98% of the atoms are replaced every year, right? Okay, then coming to numbers. Atomic number, Z, number of electrons or protons. We have seen what is an atomic number in the other class on the matter. Atomic number Z is the number of electron or proton. Why electron or proton? This is negative charge, this is positive charge, but magnitude is what we talk when we talk about atomic number. What is mass number? Number of proton and neutron. Proton plus neutron together, this is mass number. That is number of subatomic particle in the nucleus. So helium has 2p, 2n, 2e. So mass number is 2. 2 proton, 2 neutron means mass number is 2. Number of protons and neutrons in the nucleus, right? Atomic number is number of electron or proton. So mass number is same as atomic mass. Mass number, atomic mass are the same. Proton plus neutron. Lithium contains 3 proton and 4 neutron. So we call it as 7. Proton plus neutron, we call it as 7. Boron B511. What is this? This is some important thing that you need to know. How we write this? What does it mean? What you write on the left below as a subscript is called the atomic number 5. Number of electron is 5, number of proton is 5. What you write on the right hand side on the top superscript is called the mass number. Mass number is a total of the proton plus neutron. So 5 proton plus 6 neutron is 11 mass number. 11 units in the nucleus. Proton plus neutron together. 11 subatomic particles. The subatomic particles in the orbit, the electron outside is 5. So you write here 5. Proton or electron is atomic number. Proton plus neutron is the mass number or the atomic mass. So this is how we write, right? Where A is 11, Z is 5. Atomic number, number of electrons or protons in an atom, we have it here. Isotopes. Some element can have different number of neutrons. Same elements can have different number of neutrons. That means what? Boron is having 6 neutron, not 5 neutron. Then there can be another element which has either 6 neutron or 7 neutron or 5 neutron. Both are called the same name. So for example, deuterium, tritium, hydrogen, they have different mass number. Why? The number of neutrons keep changing. The number of proton plus number of electron cannot change, because if 5 is the proton, then electron has to be 5. Why? The positive and negative has to balance. But neutron can change. Why? Neutron doesn't have a positive or negative charge. So number of changes in the number of neutron will cause a different mass number for the same element. Hydrogen has 1, it is called deuterium, and it is 2, it is called tritium, and it is 3. And sometimes it may not have a neutron also, right? Isobars. Isobars are different atomic numbers but same mass number. Isotope is different mass number due to changes in the number of neutron. Isobar is different atomic number but same mass number. What is atomic number? This is the atomic number. Different atomic number, different amount of electrons but same mass number. Calcium 40, argon 40. Different atomic number, same mass number is isobar, and isotopes is different number of neutrons. Now, this is one example of the way we represent the elements in a periodic table. Hydrogen, helium, lithium, beryllium, boron, these are all gases. Carbon, nitrogen, oxygen, fluorine, neon, this corner will be all gases. Sodium, magnesium, aluminium, silicon, phosphorus, P. Calcium, Ca. Potassium, K, because Kal is the spelling in Latin. Argon, Ar, chlorine, Cl, sulfur, S. Now, is this the only thing? No, there is something more. In the periodic table, we will also be able to understand, if you look at oxygen, the red dots are the electrons. 1, 2, 3, 4, 5, 6. 1, 2. That means what? This is the K, L, M. That is how the orbits are named. Orbit K, the innermost will have 2. Next orbit, outermost will have maximum 8. This will be 2, this will be 8, 2 power 3. This is how this will expand. KLM. Electrons, in no case in the first shell or the first orbit will be more than 2. Electrons, in no case in the second shell or the second orbit will be more than 8. This is a representation of the electrons and proton plus neutron nucleus, right? This is the symbol. And then 8 proton, 8 neutron, 8 electrons. So atomic number or mass number is 8 and 16. So this is how we write in the atomic table, or what do we call the representation of the periodic table, the mass number and the atomic mass or the mass number is one and the same. Mass number and atomic mass is one and the same. Mass number and atomic mass is one and the same. It is a number of proton plus number of neutron. Atomic number is number of electron or number of proton, that is a positive relatively charged, right? Then comes the molecules. Molecules, we have seen what is a valency, the combining capacity of an element. And once we know the valency, it can be bivalent, trivalent, etc. Valency of hydrogen is taken as 1. Valency of hydrogen is standard. Valency of hydrogen is a combining capacity of hydrogen with other element. It can combine in minimum of 1 number. Valency of other element is the number of elements of hydrogen that can combine with chlorine, or number of elements of hydrogen that is displayed by that particular element like zinc or nitrogen. That is a valency. Molecules is one or two or three atoms of different elements combined together to form a molecule, the smallest particle of a compound, right? Formula is the representation of the number of elements in a compound or element. A SCERT is an element, but it is a compound. So a SCERT is 8 atoms together. O3 is ozone. It is a compound. 3 elements of oxygen together. 3 atoms of oxygen together. 1 element oxygen. Then there is no other element different, but there are 3 units to form a molecule. In ZnS, the valency is transposed. Valency of aluminum is 3, valency of chlorine is 1, valency is transposed to form the chemical formula. Sometimes it has more than one valency, 2 and 3. So Fe2O3 means valency of iron is 3, it is called iron 3 oxide, right? And then in atomic world, we have 1840 times lighter than the lightest atom. Hydrogen is the lightest atom. Electron is 1840 times lighter than the lightest atom. So lightest atom has what? A nucleus and electron. The nucleus is the mass. The proton and neutron together is what gives the mass for an atom. So this electron is 1840 times lighter than the lightest atom. And we know atom was the smallest particle earlier, but then after Dalton, Thomson, Rutherford, now we know there are subatomic particles like proton, electron, neutron, and then they are further also the mu, the d, etc. is there. Proton carries positive charge, electron carries negative charge. This is negligible mass. This mass is same as hydrogen. So how do we measure? Atomic mass unit, AMU, atomic mass unit. One hydrogen is one atomic mass unit. So proton's weight is measured based on equivalent of how many hydrogens it has. Electron's weight is 1840 times lighter than oxygen. And then we also know that neutron is 1.675 into 10 power minus 27 kilo. Electron is 9 into 10 power minus 31 kilo. Proton is 1.673 into 10 power minus 27 kilo, right? And this is 1840 times less, right? And then we have atomic mass is 1 AMU, mass of hydrogen. Mass of hydrogen is a standard against which other atoms are measured. What is nucleus? Protons and neutrons together form the nucleus. They are the mass of the atom. Electrons revolve around, they do not have on their mass. The orbits are called shells. The positive charge is due to the proton and is cancelled by the negative charge of electrons. What is atomic number? Number of protons in an atom or number of electrons in an atom is the atomic number. It is fixed for an element represented by Z. Atomic number is Z. If atomic number is Z, mass number is A, or atomic mass. Now we have isotopes, right? What is nucleate symbol? Nucleate symbol is writing this C6Z12, right? So when we have C6Z12, The 6 is the atomic number, 12 is the mass number. What is mass number? Sum of number of protons and neutrons. This is atomic number is either protons or electrons. The sum of the number of protons or electrons is atomic number. Mass number is sum of protons and neutrons. It is represented by A. So Z is protons only or electrons only, and A is protons plus neutrons. So A minus Z is neutron. Why? Because electrons and protons are equal. Neutrons is A minus Z, that is mass number minus number of protons. Nuclear symbol is on the left subscript is the atomic number, on the right superscript is the mass number. This is called the nucleide symbol. Shells K, L, M, N are the inner, K is innermost, then L, then M. K will have 2, L will have 8. That is the number of electrons. The number of electrons in each shell is fixed and it forms a pattern. This is about the atomic world, right? Now, what is isotope? Some elements have a different mass number. Chlorine has two types, 35 and 37. So, hydrogen has 1, 2, 3 or 12, carbon has 12, 13, 14. So, the number of neutron differs, and because it has a different mass number, but the element is the same, it is called isotope. It is called isotope. If number of electron and proton together increase, if electron alone increase or decrease, if proton alone decrease or increase, it will become an ion. If number of protons and number of electrons equally increase, it will become a different element or different atom. If the number of electrons and protons remain same and the neutrons increase or decrease or increments as a different number, for example, instead of 6 it becomes 8 or 7, then it is called an isotope. Isotopes are useful for so many industrial uses. Uranium is an important isotope which helps in the nuclear energy generation. Ions are what? Ions are positively or negatively charged atom. What does this mean? Atom is electrically neutral. Number of electron, number of proton is same. But when an electron is gained or lost, if an electron is lost, number of electrons will be less, it will be positively charged. If an electron is gained, number of electrons will be more, it will be negatively charged. When an electron is gained or lost, it becomes ion. When an electron is gained or lost, it becomes positively or negatively charged. Sodium becomes Na plus or Na minus. Sodium becomes Na plus or Na minus when it is gained or lost. Such atoms are called ions. In general, metals lose electrons. It will become cation. When they lose an electron, it is called cation. And then when you gain an electron, it is called anion. When you lose an electron, it is called cation. When you gain an electron, it is called anion. Metals normally lose, non-metals normally gain, right? So when you lose an electron, it is cation. When you gain an electron, it is anion, right? Number of positive charged cations is same as the number of electrons lost. Likewise, in an anion, you are gaining electron. So number of electrons gained is same as the charge of the anion. What charge? Negative charge of anion. Why negative charge? Because you are gaining electron. Only a maximum number of electrons or protons can be lost or gained. Maximum number of 3. I think only 3 electrons you can lose or gain, right? Then there is a chemical bonding. This is how bonds are formed because of attraction between the different atoms in a element or compound. Electron is lost if and only if there is another atom that can take up. If and only if another atom that can take up, or else electron cannot be lost. Likewise, it will be gained only if there is another atom willing to give up the electron. Electron lost by sodium has to compulsorily taken up by chlorine. By the way, they form the sodium chloride. Electron lost by sodium is taken up by chloride to form sodium chloride, chlorine, right? The force that brings together is called a chemical bond. Force that brings together is a chemical bond. The bond is formed after the transfer of the electron, that is, it becomes ion. So cation plus anion together will form an ionic bond. It is called electrovalent bond. Electrovalent bond or a chemical bond is formed when it is because of the ion. What is ion? An electron lost or gained, creating an ion, creating an ionic bond. So they will form a compound. The bonding occurs only when positive and negative are balanced. If sodium loses 2 electrons, chlorine has to, or oxygen has to gain 2 electrons. Positive and negative charge has to be balanced. Hydrogen has 1, 2, 3, carbon has 12, 13, 14 as the mass number, right? Now atomic world. Radicals are positive ions are called radicals. Positive ions are radical. Now we know if there is a positive charge, it is called cation, right? If there is a negative charge, it is called anion. Positive charge is cation, negative charge is anion. Metals are positive charge, non-metals are negative charge. We also know gaining of an electron will create anion. Gaining of an electron will create anion. Now positive is called radical, sodium, potassium, etc. Negative are called negative radicals. So positive radicals, negative radicals, anion, cations, right? What are the names that you have? Sodium chloride is sodium plus and chlorine negative. Magnesium is 2 manganese positive, 2 oxygen negative, it will become MgO, right? 2 has to be lost and gained electrons. Likewise, in aluminum sulfide, aluminum has to be 3, sulfur has to be 2. Only then it will become Al2S3. This is how the bonds are formed in a compound. These are simple ions. Zn2, Pb2 is lead, Al3 is aluminum, Cu is copper, simple ions. This is a compound. NO3, CO3. All these are compounds. Why? This is more than one. S2 means what? 2 sulfur is there. Because 2 sulfur is there, it is a compound. Here only one alpha will be there, so it will be, if one is there, it is an element. If more than one is there, it is a compound. This is a basic and acidic. Characteristics are acid, bases and salts we have studied, right? This is basic characteristic, acidic characteristic. Acid and base together form a salt. Acid and base together form a salt. They release energy or water, right? So compounds we know they are obtained from living organisms or natural minerals or obtained by causing chemical reaction. Sodium chloride is a compound. H2O water is a compound. Compound H2O is a natural while sodium chloride is sometimes natural, sometimes man-made. What are organic compounds? Obtained from living organisms. That means what? Plants and animals. That means what? Sucrose, sugar, cane sugar, or salt from the ocean. Salt from the ocean is organic. Most are carbon compounds. They contain C in them, carbon compounds. Inorganic are obtained from natural metals and minerals, so soil, etc., rock salt. These are mostly non-compound. But what is the specialty? Carbon dioxide, carbon oxides, carbonates, hydrocarbons are considered inorganic. When carbon is contained, it is considered as inorganic. It is, even though it comes from the living organisms, it is considered inorganic when it is a hydrocarbon. When C and H is there, it is considered as inorganic. Not necessarily it has to come from nature. What is a compound created in laboratory? Carbon. From carbon we create lot of compounds in the lab. With hydrogen we create hydrocarbon. With oxygen you create carbon oxide, then carbon nitrate, carbon sulfide. We create carbon, we mix with various elements and create so many compounds in the laboratory. So compounds are organic, inorganic or lab made. It is either from the living organism or natural materials or an effect of the chemical reactions. So thanks for watching this video. We were trying to look at atomic structure for science for class